Okay, one more time with the derivative. Actually, it's going to be two more times. I got two more problems to do. Find dy dx. Again, implicit differentiation. Remember here, this is cotangent of 3y squared quantity cubed written that way. That's what that little 3 there means. Then x minus 2y plus 5 minus e to the xy. So let's start my calculus step. Chain rule here. Start on the outside. Multiply by the exponent. Decrease the exponent by 1. Then chain rule times the derivative of the inside. And we'll take it step by step, so we'll come back and do that on the next step. So there's the first side. And so this was derivative outside. Derivative inside. Chain rule. Then getting to the other side, derivative x is 1. Derivative 2y would be 2. But I just differentiated y, so followed by dy dx. Derivative 5 would be 0. Then I get the e. It repeats. Derivative of the exponent. Repeats. Derivative exponent. So let's keep going on that. So I've got 3. Cotangent squared of 3y squared. Then I get up to here, and this derivative, another chain rule. The derivative of the outside, derivative of cotangent, is negative cosecant squared. But I don't change the angle. Then another chain rule, derivative of the inside. Derivative of 3y squared would be 6y. But I just differentiated y, so dy dx. So this was another chain rule. Derivative outside, derivative cotangent, derivative inside. But all of this was the chain rule on cotangent of 3y squared. And let's drop down because we're not going to have room, so I'm going to drop down. And instead of trying to cram it all together, drop down. So we still have that 1. We still have minus that 2 dy dx. Have the 0, so we don't need the 0. Then minus e to the xy. And then I have the derivative of the xy. And we've done this one before. A product rule. Plane first. Derivative of the second. Derivative of y would be 1, but I just differentiated y, so I follow it by dy dx. Plus plane second. Plane second. Get it right here eventually. Love the whiteout tape. Plane second, derivative of the first. Plane first. Derivative second, plane second, derivative first, and all of that was the product rule on xy. And there's all our calculus. So now it's time to solve for dy dx. So starting here and just cleaning this up a little bit, I have a 3, a negative, and a 6y for negative 18y, then cotangent squared, 3y squared, cosecant squared, 3y squared, dy dx equals 1 minus 2 dy dx then minus e to the xy, x dy dx plus y. Just cleaning it up a little bit. Next, clear my parentheses. Just clear down at the end there. So negative 18y cotangent squared 3y squared cosecant squared 3y squared dy dx equals 1 minus 2 dy dx minus x e to the xy dy dx minus y e to the xy. Then get all dy dx terms on one side, all other terms on opposite sides. And again, it doesn't matter, just do whatever thing you want. Now in this case, notice I got one term over here, it doesn't matter. I just generally go to the left. That's just my habit. Now if I go left and you go right, what we'll see in a difference of an answer is that all the terms will have a different sign. Maybe all my terms in the numerator are positive. In your answer, all the terms in the numerator would be negative. That if I go one direction, you go the other, or the computer goes one direction, you go the other, you will have the exact same answer, but every sign will just be different. They will be every single sign will be different. So if it's same terms, but every sign is different, you got the same thing. So getting all my dy dx's together, that's going to be 18y cotangent squared 3y squared cosecant squared 3y squared dy dx. There was dy dx, moving it was negative, so it becomes positive, so plus 2 dy dx. That one was negative, so that becomes plus x e to the xy dy dx equals, and all that's left then is 1 minus e to the y, excuse me, that's wrong, minus y e to the xy. Factor out a dy dx. And so I'm going to have negative 18y cotangent squared 3y squared cosecant squared 3y squared plus 2 plus x e to the xy dy dx equals 1 minus y e to the xy. And then finally, one last time, divide. And so I get dy dx equals 1 minus y e to the xy divided by negative 18 cotangent squared 3y squared cosecant squared 3y squared plus 2 plus x e to the xy. And there's my implicit derivative. Okay, moving on to the last problem. Verify that the given point is on the curve. Find the equations of the tangent and normal lines to the given point. So, kind of several steps here. We'll do one step, and then we will go to another video to do the other steps. So the first part, verify that the given point is on the curve. So that's really just saying this, that if I have this point 1 pi, that's giving me my x value and my y value. And so I should be able to take my equation and plug in those values and come up with something true. So we are wondering if 1 times pi squared plus cosine of pi, is that going to equal? Question mark. Are these things going to be equal? Pi squared minus e raised to the 1 minus 1. Are those guys going to be equal? Okay, so that's going to be pi squared. Cosine of pi is -1. Is that going to be equal to pi squared minus e to the 0? Pi squared minus 1 indeed does equal pi squared minus 1. And so we just verified. So yes, 1 pi is on the curve. That's how we verify that something's on the curve. Okay, so in the next video, we will go on with what it asked me to do, find the equations of tangent and normal lines. But we'll do that on the next video and should be the last video for this section.